All right, so this problem says for the vectors given in the following figure, use a graphical method to find the following results. Okay. Now it says graphical method, but we'll change the problem. We'll do it algebraically. Okay. So that's how you will really be solving problems. Okay. So let's do it that way. And we'll take the hardest one. We'll do this one. Okay. So lose something? No worries. All right, so we'll do this problem. I'm sorry? Yeah, I am. Yeah, thank you. Yeah. So there's the, oops. Do you see the top right, the red button that says recording? All right, so we will do problem H. Okay, minus 4D plus 2F. Okay, the first thing you want to do is write each vector in its component forms. Okay, so here is vector A. Okay, and here's the angle theta measured from the x-axis. Okay, so so A will be cosine theta I plus A sine theta j. Okay, these are all two-dimensional vectors. Okay. I'll do one decimal place. Okay. So you want to do all your vectors in component form, okay, and then you can add or subtract or whatever you want to do with them easily. So D is, okay, here's the vector D. Okay. Now, you can measure the angle from the x-axis, and from the x-axis the angle is 143 degrees. Okay, and if you put that in this formula, it'll take care of the sine on its own. But what is useful to get used to is the following. Just figure out this distance, and then you put in the sine by hand. Okay, and for that we'll just use this angle. Okay, so what is this distance? This is the opposite side, d sine 37. And what is this distance? D cosine 37. Okay, and that is in the second quadrant, so that will be negative x component, and that's a positive y component. Okay. All right, so D is minus, I'm putting the sign by hand, D cosine 37 I plus D sine 37J. Okay. And just to make sure we understand this, so if you didn't want to do that and not take care of the sine by hand, you can measure the angle from the x-axis, and that will take care of the sine. But again, like I said, oftentimes that is a little more cumbersome. Okay, so I like to use an acute angle. I like to use this angle. Okay, and do it that way. All right, so D is 20 cosine 37 I plus 20 sine. Okay. Okay, so there's D. Let's make a little room. Okay, the last one we have to figure out is F. And again, F, we will do these two distances. That is F cosine 30. And that's F sine 30. Okay. So F is minus 20 cosine 30 I minus 20 sine 30 J. Everybody understand that? Okay. So this is a this will work out to be 17.4 I minus 10 J. All right. All right, so now that we have components, now you can do anything you want. It's very easy. It's just plain algebra. Okay. So if you wanted to find what we want to find is A minus 4D plus 2F. So A minus 4D plus 2F. Let's call that R for the resultant vector. And so the x component of that is AX minus 4DX plus 2FXI plus AY minus 4DY plus 2FYJ. Okay? And of course, if the vectors had a third component, a z component, you would have a corresponding formula for the z component. Okay? All right, so now it's just a matter of adding all those up. AX is, there is AX. Okay, B, DX is that, and okay, FX is that. So I just have to remember all of that. So AX is 8.7 minus 4, DX is 16. Okay. Plus 2 there is the x component, and similarly y 5, 12. Okay. So that's 64, 34.8, 29.2, 37.9. And that's 60, 80, 75. So minus 75. All right, we'll do a couple more things with this vector just so you know all the manipulations. Okay, so if you wanted to draw this vector, here's your x-axis, here's your y-axis. It's the x component is positive, the y component is negative, so it's in the fourth quadrant. Okay, so the vector is something like that. Okay. Okay, now what we'll do is we'll also find the angle. Okay, so the magnitude and angle. This would be theta. This would be phi. Okay, phi would be negative. Okay. All right. So what is the magnitude of r? It's just that it's rx plus minus 75 squared. Okay. and theta is tan inverse of ry over rx, tan inverse of minus 75 over 37.9, so minus 63 degrees. Okay, so what we have found is phi, and this is the solution. So minus 63.2 degrees. Okay, yep.
I might be wrong, but I think that the arithmetic is slightly off. 5 minus 48 minus 20 is negative 63, not negative 75, right?
5 minus, no, you multiply these two first.
Yeah, yes, which is
60,
Which is
oh,
negative
48,
48.
okay, yeah, okay. All right, so what is that? 48, 68, 63. All right, so fix everything. Okay. All right, what is this? What is the magnitude? All right, you guys can figure it out. For the angle? No. For the magnitude. 59 degrees. All right, and you guys can figure out the magnitude. All right? All right, so let me summarize this again. Okay. So going back, if you want to add, subtract, and do all kinds of things with vectors, what you want to do is you want to get the components of each vector first. Okay? Once you get the components, then you can do anything you want. If you want to add a bunch of vectors, you just add the components, corresponding components. Okay? So that's what you want to do. You want to get their components first and then manipulate the vectors. Okay? That's the idea. All right, any questions before we move on to the next problem? Yep.
You use phi for your new angle with respect to your x and y components.
Okay.
My question is, will Ms. Davy using that notation in the book when asking questions? Will they ask for phi?
Okay, so here's the deal. Okay, so tan, the angle is tan inverse of ry over rx. Okay, and this has two solutions. Well, okay, so theta and theta plus 180 degrees. Okay, and the way you know which solution to pick is, see, if ry is negative and rx is positive, so tan inverse of negative over a positive, this is an angle in the fourth quadrant. Okay, and tan inverse of positive divided by negative, see, this number is the same if you have the same numbers. Okay, but this angle, that's positive, negative, that's in the second quadrant. Okay, so going back to our problem, so that's how you decide. Okay, so you knew that your resultant vector is in the fourth quadrant. The two solutions are, okay, so I should write both the solutions. So tan inverse, this has two solutions, minus 59 degrees and minus 59 plus 180 degrees, which is 121 degrees. Okay? And from the components, you know, this is the correct solution and this is not the correct. Okay? So that's how you pick the solution. Yep. All right, any other questions? Yep.
The R, what does that stand for? Like resulting factor?
Yeah, the resultant vector. Yeah. Yeah. You can call it anything you want. A, B. Well, you don't want to call it A, but anything. Yeah. Any other questions? Okay. I'm not going to do every problem. I'm going to do a representative few. Okay. All right. This is adding a bunch of vectors. I'll just draw one or two vectors, okay? And then you can do the same thing. It's adding a bunch of vectors, so what do you do? When you add a bunch of vectors, you first get the components and then add them, okay? So let's just translate a couple of, okay. So in an attempt to escape a desert island, a castaway builds a raft and sets out to sea. The wind shifts a great deal during the day, and he's blown along the following directions. 2.5 kilometers, 45 degrees north of west. So the first vector, okay, this is north, this is west, 45 degrees north of west. Okay. That would be 45 degrees, and we'll call that A, and this is, the magnitude is 2.5 kilometers. Okay. So that would be that vector. Then 4.7 kilometers, 60 degrees south of east. So vector B would be 60 degrees. Okay, and so on. And then you can add all the vectors. Okay. Do you guys understand that? Do you want me to do that? Or you guys are good? You want me to do that? All right. So actually what I'm going to do is all right, south of east, then 1.3 kilometers and 25 degrees south of west. 1.3 kilometers, 25 degrees south of west. Okay, and we'll cut off at that. We'll just, okay. So he's only going on 3 legs of his journey. Okay, so we'll call it resultant again. A1 plus A2 plus A3. Okay. All right, again, when you want to add vectors, what is it that you're doing? You're finding the components first, okay? So, by the way, this is a useful thing to do. So let's do it graphically first. So here's a starting point. There is A1, okay? And again, to do it graphically, you would have to draw it to scale and all that, and that's kind of hard to do. There is A2, and then there is A3. Okay, so this would be his final location. The resultant is that. Okay, and what the picture shows you is that the resultant vector is in the 3rd quadrant, assuming I've drawn it to scale. Okay, if I haven't drawn it to scale, then this method will tell us the accurate answer. Okay, but this gives you a sense for it. Okay, so So at least we know it's either in the second or the third quadrant. Okay. What does that mean? The x component should work out to be negative. Okay. All right. All right. So let's find the components. Okay. So A1 is negative 2.5 cosine 45i plus 2.5 sine 45. Okay. All right, so there's A1. A2 is 4.7 cosine 60i minus 4.7 sine 60j. Okay, so now we have the three vectors. So R is minus 1.8 plus 2.35 minus 1.2i plus okay, so that's 3, so minus 0.65i, and that is 4.1 and 65, 4.65, and so 2, that's, we'll subtract 2, so minus 2.65 and then add 0.2, so minus 2.85. Okay. So again, whenever you work with vectors, get their components first and then you can do all kinds of stuff. Yeah.
So that's how you add vectors when you're getting a magnitude in the direction. You're using a sign.
Yeah. So you're finding their components first.
Thank you.
Yep. All right. Any questions? All right. So let's. Yep.
When given a question like this,
Mhm.
we'll have about 3 answers. One for
I'm sorry?
If you want the able to finish.
Yeah, I mean, you answer whatever the question asks. So for instance, um, if you're just wanting the components, you're finding the components. I'll just do 2. That's component. And the magnitude is, those formulas. And okay, so whenever you do algebra, you're always finding the components first for the resultant and stuff like that. And then if the answer wants magnitude and direction, then you do another step. Okay. Yeah. All right. Okay. So this problem says given 2 displacement vectors, A equal to that and that, find the displacement and their magnitude for displacements and magnitude for C equal to that, D equal to that. All right, we'll do this one. Okay, again, now, see, life is easy here, except that we're working with 3-dimensional vectors. They already have given vectors in component form. Okay, so this is half the battle has already been fought. Okay, so we'll do D and so it's 2ax minus bxi plus 2ay minus byj 2az minus bz. Okay. Hey guys, if I can hear you, all those people can hear it. All right, so ax is that, so that's 6 minus 2, 4i plus, you guys understand? 2 times 3 is 6, minus 2 is 4, 6 minus 2 is 4. Then ay, that's minus 8 minus 3. So minus 11j. Yeah. And then that's 8 minus of minus 7 is 15. So plus 15. Okay. All right. And what we'll do is find the magnitudes. So there's the vector display, and the magnitude of D is, of course, okay. Yep.
Can you find data with 3-dimensional?
Okay, so how many angles are there for a 3-dimensional vector? How many angles, how many angles do you need to specify the 3-dimensional vector? 2. So if you have an n-dimensional vector, 1 number for magnitude and n minus 1 for angles. Okay, so this one is hard to draw, but let's see if I can. So here is a right-handed coordinate system. Okay, and this vector has a positive x component, negative y component, and positive z component. Okay, so this is a vector. Well, I guess it's I don't, this is hard to draw. So D is pointing somewhere like that, okay? And so you would need two angles. All right, let me try and draw it properly. Okay, so no, I can't draw. All right. No, so okay, let's see. No, because all right, so that's the magnitude. Okay. So what I can show you is the following. Again, I can remind you. Okay, so here is something that I can easily draw, and this is a matter of. So let's say this is a vector A. You would find these two angles. Theta would be one angle. So here's a projection of the vector A in the xy plane, and this is the other angle that you would find. Okay. Yep.
I was just asking if on the test or on any test or anything, it would ask us for those angles, or just normally need a component form, or what types of things the questions might be asking.
Whatever these problems that we're doing, that's
Because I didn't run into any practice problems that you suggested that had where you had to find those two angles.
yeah. Then it won't be on the test. Okay. So as an older guy, my advice to you is, well, this is a general comment, not just to you. You got to go beyond thinking about tests. Just worry about learning stuff. Okay. All right. We'll do this problem. This is slightly different than what we've done. Okay, so they give you vector D and B, and notice they're giving you components. So they're already understand that you've gone to the next level. They don't want you to bother about, I mean, they're making life easy for you. You don't have to find components. Okay, so they give you D and B and A. So three vectors, and they're asking you find the unknown constants A and B such that A times D plus B times B plus A equal to 0. Okay, so they're asking you to find two unknowns, A and B. How many equations do you need to find two unknowns? Two. Here's one equation. So how are you going to solve this problem? You guys understand the question?
So, plug in the x values in that, and then do the number and y values.
So what she said is the following, very good. Okay, when you equate two vectors are equal to each other when their corresponding components are equal. So this is not one equation. If the vector is n-dimensional, that's really n equations. Okay, so what this is ax equal to bx. That's what our friend just said. That's when two vectors are equal, when their corresponding components are equal. Okay, so if the vectors were three-dimensionals, then you would have three equations. Okay? All right, so this is really two equations, and so you can solve it. Okay, so what this is saying is a times dx. Okay, the 0 vector is 0I plus 0j. Okay, since we're dealing in two dimensions. So what this is really is ax dx plus b bx plus ax equal to 0. Okay, and a dy plus b by plus ay equal to 0. Okay, so the x component of that is the sum of the x component is that, the sum of the y component is that. Okay? So now you have two equations and you can solve for the two unknowns. Okay. All right, so let's plug in those values. So 6a dx is 6, 6a plus bx is minus 8 minus 8b plus 26 equal to 0. That's equation 1. And dy is minus 8a by is 3 plus 3 all right, now you know how to solve this. Okay, so again, all the techniques that you learn is they amount to the following: n unknowns and n equations. What you do is all the you learn how to do it using determinants and all, but they essentially boil down to the following, and so on till you get one equation and one unknown. Okay, and then you solve that. Okay, so what we're going to do is we have two unknowns and two equations. We're going to reduce it to one unknown and one equation, solve for that, and then solve for the other unknown. Okay, so here's a simple trick. You can see that you can get a common multiple, add these two equations, then the a's will cancel. Okay, so we'll multiply this equation by 4 and this equation by 3. Okay, and you'll get the same quotient 24, add the two equations, and that'll cancel that. So you will end up doing this step. Okay, all right, so I'm going to erase this part. So 1 prime, I'm going to multiply this equation by 4. So 24a minus 32b, and I'm going to bring this to the other side. 4 times that is 104. Okay, so minus 104. We'll call that equation 1 prime. Multiply this by 3, that is minus 24a plus 9b, and that is 57. That is equation 2 prime. All right, I don't want to mess it up. Okay. Add the two equations and you get minus 23b equal to minus 161. Okay, so b is 61, 7. Is it 7? Yep. All right, and then now you can plug this in. 6a minus 56 plus 26. Okay. All right, so the crucial thing to note was, so this is a vector. When a vector is equal to another vector, two vectors are equal to each other when their corresponding components are equal. Okay. All right, any questions on this before we move on?
What would the corresponding component, the i's and the j's?
Yeah. All right, so this is a dot product problem. Whenever they ask you find the angle between vectors, okay, and again this is a general thing. So for instance, if you remember the dot product of two vectors A and B involves the angle between the two vectors, okay, is A B cosine theta. All right, so and this dot product can also be written in terms of components, ax bx plus ay by plus az bz. All right, so if you wanted to find the angle, you would need to know the magnitude of the vectors and you would need to know the components. Okay, and so in this problem, you see, we'll do part B because they are three-dimensional. We know the components, you can find the magnitudes, and so you can use this equation to solve for theta. Okay. All right, so we'll change that to D. All right, so cosine theta is dx bx plus dy by plus dz bz divided by dB. All right, so let's find the magnitudes D. You guys are following this? You guys all understanding this? All right, so D is 2 square plus minus 4. Okay, that's 421 square root. Okay. And the magnitude of B is, and again, by the way, these are in meters, so I've been neglecting to write the units, but okay, 4, 8 plus 9, 17. Okay. All right, so now we have found the two terms in the denominator, and now we'll do the numerator. So dx bx is, so I'll write it right here. That is that's minus 4. dy by is minus 12 and plus 2 divided by 4.58 into 4.12. Okay, so that is 16 minus 14 divided by Okay, so the two vectors are 140 degrees apart. That's what you found. Yep. All right, so whenever they ask you to find the angle between two vectors, you're using the dot product. Yep. All right. So now we'll do a cross product problem. Yep. And again, I'm just doing one sample each. You guys can figure out the others. And you are lucky you have Abdul to help you guys. Okay. All right, so we'll find a cross product. Okay. And let's pick. All right, we can do A because it is three components. B, well, that's also three components. So A or B, it doesn't matter. All right, so let's, any preference? They'll look the same. Okay, so A is 2I minus 4J plus K. C is 3I plus 4J plus 10K. All right, so a couple of things about the cross product. Okay, again, the result is a vector. And you know that, so A, if this is the plane containing A and C, what is the direction of the resultant vector? Again, you turn a screw from A to C, the screw would move in that direction. That would be the direction of the resultant. Okay, so the resultant vector is perpendicular to the plane containing these two vectors. Okay, so all that information will be in here. Okay, and again, if you wanted to know the magnitude for A cross C, you have seen a formula. The magnitude is A, magnitude of A times magnitude of C times sine theta. Okay, but we're finding the whole vector, so but all that information will be there. Okay. All right, now I'll write down the formula for A cross C. Okay. Again, I'll show you how I remember it. Okay. I, J, K. Okay. So you want the I component, it's AJ, CZ. Okay. Okay. So the I component is AY, CZ, and then the opposite of that, AZ, CY. Okay. The X component of the vector does not have X components of the other two vectors. Okay. Plus the Y component. For the Y component, it's AZ, the first vector Z component, the second vector X component. Okay. All right. The Z component is AX, CY. Okay. There's the components. All right, so now let's write this down. Okay, AYCZ. There's AYCZ, that's minus 40, minus AZCY, AZCY, that's 1 times 4 is 4, minus 4. Plus AZCX, that's 3 minus 20. Yes, so 3 minus 20J. plus the z component is axcy, that's 8 minus of minus 12, that's plus 20. Yep. So the cross product which we gave the name R for the resultant vector is minus 44I minus 17J plus 20K. Yep. All right. So if you wanted a challenging problem, you could go home and verify this. You can check this formula. So we said the magnitude of the cross product is given by the magnitude of A times the magnitude of C times sine of the angle between the two. Okay? So here's an interesting problem for you. Magnitude of A can be found here. Magnitude of C can be found here. How do you find the magnitude of this can be found here, the left-hand side? How do you find the angle theta? We just did a problem. So you use the dot product formula, okay? Find the angle theta and then verify this, okay? So you can go. Mm-hmm.
When we are dealing with dot products, what's the determining factor in each question that we're giving that will allow us to know whether we're dealing with a scalar product or a vector?
Oh, well, whenever they ask you for the angle between vectors, then you're dealing with the dot product, generally. Mm-hmm. All right, so we did a problem on cross products. Do you guys understand this? All right. Are we good with this, or do you want to see another example? I'd rather not. Yeah, go ahead.
So it starts with AY and then CZ. Why did it start with Y instead of like X, Y, and then YX? Why would it start with the Y first?
Well, that's the definition. So here, A cross C is I, J, K. It's this determinant, X, A, Y, A, Z. And I don't know if you've done determinants, and when you expand this in terms of minors, it's I times this is the minor you multiply it with, and there's a minus 1 to the power, first row, first column, so minus 1 to the power 1 plus 1. That's all right. Are we good with cross products? We're good? So, all right. Yep.
The difference between dot products and cross products is dot products, you're multiplying the x's together, the y's together, the b's together, and cross product, you can make a matrix.
Yep. So what is the big difference between them? When you do a dot product, the result is a scalar.
Yes.
When you do a cross product, the result is a vector. That's yep. All right, so here's another dot product problem. Okay, so to answer your question, okay. So a stubborn dog is being walked on a leash by its owner. At one point, the dog encounters an interesting scent at some spot on the ground and wants to explore it in detail, but the owner gets impatient and pulls on the leash with a force. So there's the force that the owner applies along the leash. What is the magnitude of the pulling force, and what angle does the leash make with the vertical? Okay, so we'll do this. Okay, so we'll do part B. Okay, now it says what angle does the leash make with the vertical. So what we'll use is, so you need a vector in the vertical direction, and here's the vector we'll use. What is k?
It's a unit vector.
It's very good, and it's pointing in the z direction. Okay, so we want to find the angle, okay, with the vertical. So k dot f gives you, what is the magnitude of k? 1. That's why we used it. And the magnitude and cosine theta, where this is f, this is k, and that's angle theta. And that's what we wanted to find. Okay? All right. And this is equal to, here's another nice thing about it. So what is the x component of k? So here is k written in terms of components. Very good. 0i, 0j plus k. All right, so this is 0 times fx plus 0 times fy plus 1 times fz. Okay. All right. So what we have is f cosine theta is equal to fz. Okay, so this formula, so now we find, so to find the angle theta, you just need the magnitude. So cosine theta is fz over f. Okay. So that's the angle the vector f makes with the z-axis. What if you wanted to find the angle that the vector makes with the x-axis? So this is the angle with the z-axis. You guys understand? This would be any vector, the angle it makes with the x-axis. Okay? Now help me out with this guy. Fy over fz. F. Okay, so now you've learned a formula to calculate, to find the angle any vector makes with any axis. Okay? So if you wanted to find the angle that a vector makes with the x-axis, you just take the x component divided by the magnitude. Okay, so the problem was useful for that. All right, so this is fz is 32 and the magnitude is 98 square plus 1. Okay. makes an angle of 79 degrees with the z-axis. And that makes sense, when you're unless it's a horse that you have on a leash, the leash will make a large angle with the vertical. Okay, so we will do one of these guys. Okay. Okay. So they say find the scalar components of the three-dimensional vectors g and h. So there's h, there's the vector h, x, y, z. So it shows you the vector is in, it's pointing there. So we want to find the components of h. So yep. Now, you just saw that well, let me show the diagram and then I'll show you a quick way of doing it using these formulas that we just figured out. Okay. All right. So, essentially we're going to do the same. Okay. The magnitude of h is that the z component, okay, hz is h cosine 45. Okay. So you're looking at this triangle. You see this triangle, and this side is h cosine 45. You guys understand? Okay. So hz is h cosine 45, which is 15 cosine 45, and okay, so we have hz. Now to find the x, so the x component, what we need is the shadow of h on the xy plane. Okay, and since that is 45 degrees, that is also 45 degrees. Okay, you guys understand? Okay, so here the vertical, this angle is 45 degrees, that angle is 90 degrees, so that is 45 degrees. So this guy is also h cosine 45, which is 10.6. Okay. What is the x component? There is the x component. This guy is, okay, so h, okay, this angle is 30 degrees, so this angle is 60 degrees. Okay. Minus h cosine 45, that is this fella, okay, and cosine 60. Okay, so you're taking two projections. Did we understand that? The negative sign comes from the fact that it's pointing along the negative x-axis, and this just gives you the magnitude of that. All right, so this is negative 15 cosine 45, that's 10.6 times cosine 60. hx is that. What would hy be? Hy, this is h cosine 45, cosine 30 of that would be hy. Okay. And that's in the positive y direction, so hy is h cosine 45 times cosine 30. All right, so our vector h is minus 5.3 I plus 9.2 j plus 10.6 k. All right, so now here's another thing I want you guys to get used to and following. Okay, so you did a multi-step process. Oops. So you did a multi-step problem. Okay, it behooves you to go verify it. And if you start here again, psychologically you're likely to, if you made a mistake, you're going to probably make the same mistake. So you want to have some sort of a cross check. Okay, well, they've given you the magnitude to begin with. Now calculate the magnitude using this formula, and if it cross checks, then you've probably done right. Okay. Of course, that doesn't guarantee it because there could be two mistakes, but here's a simple cross check. Let's do this. Okay, so you want to get in the habit after a long calculation. You want to get in the habit of doing a cross check. Okay. It does work out to 15. Okay. All right. Do we have any questions on that? We understand that? All right. So we will stop here.